Hi, Zach and I are really excited to be talking to you here today. We've got a completely new offering from Neo4j. As you will have heard in Sadir's roadmap session, we're a cloud-first company, and whilst we've been on AWS, Azure, and GCP for some years, we're here today to talk to you about how we're bringing graph data science to Snowflake's AI data cloud. We're currently in private preview. But some breaking news just today, we've been approved by the Snowflake team to move from into a public preview listing. This is really exciting phase of the product for us. So with me today, I have Zach, who I'm sure many of you are familiar. He's our AI and ML product specialist, produced lots of great GDS content, and he'll be doing a great demo showing some fraud detection. I'll be providing a product overview, going a bit under the hood, how it all kind of works, talk about the deployment from the marketplace, and importantly, my main task is to make sure that Zach has plenty of time for his demo. I'm Stu Moore, the product manager for sort of Neo4j's data ecosystem integrations. But first, let's just take a quick look at why companies use Snowflake. So their AI data cloud provides this data foundation for businesses to consolidate their data securely within their organization and across sort of data providers and the partners that they use. It enables them to ensure high quality data and super important like governance, especially as these are kind of the foundations for AI models and apps, and ensure that data is secure. They're seeking to bring the kind of AI models and the capabilities to where the data is, rather than moving the data to where AI is, and this helps preserve the data governance. The data cloud is kind of a global network that connects data, applications, and services, and they're essential for businesses. There are kind of two key elements. There's the Snowflake platform itself, provides the unique architecture, data types, workloads, and runtimes. And then there's the content, thousands of data sets and applications that your business can rely on. So when we consider many of today's business problems, and we're sure none of this is going to be news to many of the folk here at Nodes, but we're looking to see how we can make recommendations to customers, identify suspicious activity like smurfing, where you pass payments around below financial reporting levels, identity theft, where multiple loan applications may be seen and submitted with common and stolen personal identity information. And then you've got like customer 360, where the same customer might be coming in through different systems, but you have partial information and you're looking to perform entity resolution or find the fastest route through a disrupted supply chain. And as we all know, like making sense of data requires understanding of the relationships, and the graph are really well suited to that. Enables you to uncover what's important or influential within a network, who's acting suspiciously within the payment network, or where applications might be sharing email or social security numbers, and figuring out like what's your next best action for your customer 360. So for many years, Neo4j's graph data science has offered the largest catalog of graph algorithms, page rank and degree centrality, which can help solve fraud detection, manufacturing supply chain problems with shortest path or between centrality. And importantly, the ability to iterate fast with different algorithms and bring your models into the context of your connected data in the pipelines. So when we think about how we can solve these problems within Snowflake, we've heard Neo4j have had customers with Snowflake for a good few years, and what many of them would like is to be able to run these algorithms directly within Snowflake. They've consolidated their data into the platform, So we're looking to offer a way of running algorithms directly from within SQL data, not requiring any data migration or ETL, and maintain the existing permissions and security model that exists within Snowflake. And importantly, like being able to utilize the serverless infrastructure. If any of you out there on this session caught the strawberry session earlier, then you probably got an idea of kind of what's coming in how we're building and what we're building. So let's take a look at what we're offering then. So Snowflake offer a compute platform called Snowpark Container Services. It's currently available on AWS in combination with native applications. Native applications are a way for companies like ourselves to build our products and have them available within Snowflake's marketplace. So you'll be able to click and deploy Neo4j GDS onto their compute platform, access your data tables all securely within your account, and importantly then be able to run and create GDS projections, run algorithms all through SQL. As much as Neo4j loves Cypher, obviously we recognize not everyone in the world knows Cypher, and the opportunity to enable people access to our algorithms through SQL is clearly beneficial to data scientists and engineers out there. So if we look under the hood, what we have is our container goes through security scanning. When we submit it to Snowflake, it's just passed a functional test review as well, which ensures ease of use, which is how we'll be getting the by request listing. We deploy in and create an application database which contains all the service functions for each of the algorithms, the commands to stop and start and create sessions. And they map to HTTP endpoints within the container running on Kubernetes. You'll notice that there's just GDS in there. There's no database. So all the persistence is managed and done through the Snowflake tables. So you read and write from Snowflake using JDBC. To create a projection then through SQL, you do select, you use the graph project, you specify the name of the graph that you want to create, and you provide a table of nodes and a table of relationships. We support views as well, so you don't have to have exactly the same table. Then to run the algorithm, and here we're showing an example of weakly connected components. Zach will be showing some others later. You specify the component ID, the property you want to change within the graph. You can specify the concurrency level, the number of vCPUs you're using. If you don't specify that, it will default to 4. Once you've run the algorithm, you're then able to write your results back to the graph, back to the table within Snowflake, and then run SQL as you would normally and combine it with other tables within your data set. So if we look at the life cycle of a session, we create a session, that's when you start, and it's worth saying that there's no license for GDS. You're not paying a subscription. This is a pay-as-you-go product, so you pay for credits for your Snowflake compute pool, and you pay us for the time that sessions are running. So you create a session, you then project the graph, you run the algorithms, you write the node properties back to the Snowflake tables, and then you can stop a session and then you stop paying. To deploy, it's super straightforward. You just click get the app when it's available to you. There's embedded documentation within the application. It includes some code to just configure your app and your tables with the required privileges, and then away you go. It's got some links out to our GDS documentation. All the syntax is exactly the same for our algorithms. They're just accessed through SQL. And one of our early access customers, Redefine, their mission is really around using blockchain for security and compliance and risk assessment. And they're enabling their organizations to assess indirect exposure to risk, which may be kind of missed by traditional risk analysis methods. And they do this through calculating a quantitative measure of risk by examining the transfer that occurred between addresses for up to 3 degrees separation from a sanctioned entity. And they've been really impressed with the product offering. Just talk quickly, just a bit about some performance that we've got. We're still early in our preview, but we've got some great performance results already. We've done 0.2 billion nodes and 1 billion relationships in about 9 minutes. Running PageRank over there took 3 minutes, and then writing the results back in 12. So now I'm going to hand over to Zach. Zach's going to take you through a payment fraud example. Over to you, Zach.
Awesome, thank you. Now all I need to do is figure out how to share my screen. Here we go. It's funny how it seems like the more I work on demos, the less capable I am at simple screen share.
Yes, I know the feeling.
So the data that we'll be looking at today is going to be from a peer-to-peer payment platform. So think of this kind of like a Venmo, where basically this is the data schema here. You have these user accounts, and the primary relationship that we're going to be looking at is this P2P relationship, which is going to be showing you how different users are sending cash to one another inside of the application. And there's going to be some other data that we have here, particularly these users are going to have different credit cards, devices, and identifiers like IP addresses. And so basically what happens is if we were to look at what a sample of this data looks like, and I don't know how viewable this is through the nodes portal here, but basically as you start looking at all of these transactions and all of the identifiers that some of these accounts share, this really turns into a graph. So you get sort of some of these globs, right, of users and other sort of smaller components that you see out here on the left. And basically what we're going to do today is 3 things. The first thing that I want to walk through is how to identify user clusters. So this is going to be similar to a customer segmentation exercise, where we're going to find users that are often transacting within their own groups. And this sort of pattern applies also to if you had like co-purchasing data on an e-commerce website, or if you had marketing data, the ability to do that customer segmentation and find different components in the graph where users are often transacting over similar items. And then along with that, we're going to find who are the most influential users inside of our graph. And in this case, it's going to mean who's has the most money flowing through their accounts, which again could be an indicator of something like fraud, but could also just be an indicator of the most sort of influential or most active users inside of the network. And then the third thing we're going to look at is actually performing entity resolution and using that to identify other fraud risk accounts based on other manually identified flags from analysts that have been identified earlier in the data. So I'm going to start here by going into Snowflake. And what you're looking at right now, I'm inside of a Snowflake worksheet. And I've created this application called P2P ML app. And this application is using Graph Data Science, the Snowflake container. And I just ran the function here to show all the different algorithms that we have available. So there's a huge list of algorithms available. We'll only use a few of them in our short demo today. The data that we'll be using here, there's a couple important tables. So this first one is the user table. And basically every node ID is like the user ID for the node that we saw in the schema earlier. And then they also have this metadata about IP addresses and number of cards and devices. And then there's this fraud flag. And so this is a very sparse flag inside of the database. But basically what it tells you is users that have been manually identified as being fraudulent. In this case, it has to do with chargeback fraud. But again, it's very sparse, and we'll be getting into that later and leveraging that property. And then the other second important table I wanted to show you here is this P2P aggregate transactions. And basically what this is telling you is it's saying from this user ID, this source user ID to this target user ID, what's the total amount of money that's been sent? So this could be multiple transactions that are aggregated together. And this is a fairly large, hundreds of thousands. I think it's tens of thousands for this sample of just transactions going back and forth between users. And so this creates a graph. And so I'm going to start in on that customer segmentation exercise now. And so the first step that I have is creating the graph projection. And basically what this does is it creates my in-memory graph using those users as nodes and using that aggregation table, those transactions as relationships. And then once that's complete, I can go ahead and run my algorithm that's going to do community detection for me. And the algorithm we're running here is called Louvain. And it uses these modularity sort of mathematics, where if I was to look at it, it will create these communities where it finds users that are highly interconnected through these transactions. And it will give you some output metrics to tell you and what you see a lot of times in these graphs is you'll get a lot of, small clusters of ones and twos, but then you'll get sort of this high tail end of larger clusters once you get over the sort of 95th and 99th percentile in terms of the size of the clusters you create. And of course, to complete that, we can write that back to a table, and then I'll just run both of these lines at the same time. So that basically you'll see here, I'm writing that community ID back to the table, and then I'm basically just going to show you what that table looks like once it's done writing back. And what that will show you here is I'll get my user IDs, my node IDs here, and then my community IDs. And you'll see there'll be a couple here where you'll have this is a group of 2, and then you'll see some groups of 3 as I move down, so on and so forth. And then really quickly, what I'll do is I'll also run the page rank score. So basically, I'm going to repeat sort of the last 3 steps that I just showed you in here. And what I'm doing is I'm running something called PageRank. So again, the same transaction graph projection, and it's going to create this score. And what this score will tell me is at a comparative level, what users have the most money going through their account. So the most transactions between different users going through their account. And then I can get this nice ordered list where I see sort of the most active users on top, and then going down the data set to less and less active users. So once I do that, just to kind of visually show you what that looks like, I can start making interesting analyses on my data. So I've loaded this into a notebook, and there's a lot of tables here. But basically, the main thing that I've done is I've created this pivot table inside of SQL using, inside of Snowflake, where I've taken the Louvain IDs and I've just counted the amount of users inside of each one, sort of going down here in descending order. And then I can also do some visualization inside of Snowflake. This could also be like inside of a Streamlit app, where I can visualize, I can pick a certain community ID, right? Like in this case, it's community number 9,440. And I can understand what that community looks like, and you can imagine if this is customer segmentation or something else, you can imagine looking at sort of what this community of users looks like and the types of transactions that they're engaging in. And then sort of the larger the node with the bigger and the redder it is, the higher the page rank is, sort of the more money they have flowing through that account. And I can even go through and select different ones as well here to kind of understand the different communities. So another cool thing that we can do with this is, in addition to sort of doing that analytics and grabbing interesting sort of community and page rank signals, is I can use this to label additional accounts in a fraud detection setting. So oftentimes what happens, if I go back to my original script here, is when we have fraud detection going on inside of anywhere where someone can obfuscate their identity, entity resolution becomes really important, because basically if people are creating multiple accounts where they're conducting different forms of fraud, it's important to see, well, can I link between those accounts and find common identifiers so that when someone previously made an account and committed fraud, can I identify next accounts that are likely to commit fraud as well based on those identifiers? And so oftentimes we have business rules that help us identify what accounts might actually be in the same household, or might be the same community of people, or the same exact person. It might be something like, hey, if someone shares a credit card, right? That's a very simple rule. Or it could be, a certain number of IP addresses, or a name, or a combination of a name and a credit card in certain transactions. And in this case, I've just created a simple table. For this data set, we used some business logic around transactions and cards that basically tells me whether 2 user accounts should be resolved to the same community. And that creates a relationship between users, pairwise relationships. And what I can do is I can run similar community detection algorithms. In this case, I'm going to use something called weakly connected components. And what that will do for me, if I just run this whole block here, is it will effectively create, like we had with Louvain, different communities over those resolved entity relationships. So I get back my WCC weakly connected component IDs, and you'll see here I'll get the same with two, ID number 6 having 2 users in it, and etc. So the difference between this and Louvain, which we were looking at earlier, is this is a deterministic community detection algorithm, meaning that when it does its partitioning of the graph, it does it just based on the relationships deterministically. So for example, the 2 nodes inside of this community, these 2 users only have links, identity links inside of this community. They don't have any identity links to other users outside of that. So it's very useful in an entity resolution scenario when you want a deterministic solution for doing entity blocking, or doing the actual entity resolution step like we've done here. And then because now we have this as a table in Snowflake, we can create a view out of this. So I can go ahead here and create a view out of my new sort of entity resolution. And that'll give me basically my WCC ID. I basically just aggregated I did like a pivot table, right, on the WCC ID. And then I have a list of user IDs here. And I have user counts for each one. And you can see some of these are quite sizable. And if there was any user inside of that group that had a fraud flag, this column will be 1. Otherwise, it will be 0. And that becomes very useful, because essentially what I can do with that graph logic in my notebook here. So recall, right, we had the fraud flag that was very sparse, where we have just a few users or a handful of users that have a fraud label that was manually labeled. Once I create that, it basically allows me to say, well, these other, 22 users inside of this group, they should probably also have a fraud risk label associated with them. And so I'm using the logic and the, algorithms inside of this graph to expand my labeling essentially. And when we do that, there's some other SQL that I do here to kind of wrap features. This is not super, super important, but at the end of the day, what I can do is say, okay, well, I started out with 241 flagged accounts. And by doing this entity resolution, I'm able to identify another 158 fraud risks based on that business logic that I had, kind of using the multi-hop algorithms inside of the graph, which is over a 50% increase in my ability to label fraud. So using these graph algorithms, I just wanted to show you in Snowflake SQL how it's easy to kind of do these very short few step procedures to where I can perform customer segmentation, identify different communities, identify influential users, and also affect metrics like being able to perform entity resolution and identify new fraud risks and perform extra labeling inside of my data set. So that concludes my demo. And from here, I guess, should I pass it back to you, Stu, for covering anything to close us out?
Yeah, sure. I was just going to just put up a slide of resources that will be including in the slide deck when that becomes available. But yeah. Where's the reshare button?
I have it on the top left. It says screen.
Oh, yeah. I see what you mean. Yes. Cool. So yeah, this was first announced a few months back. We've got the link to the press release and the blog. If you want to sign up and join the early access preview, please follow and click that link. As I said, hopefully next week we'll have a by request listing actually inside of the Snowflake Marketplace, which means you'll be able to go in, search Neo4j GDS. You'll see our listing. You'll have a button to request the application, and then we'll be able to get in touch with you and arrange follow-ups and provide the application to your Snowflake account. So we've probably got a couple of minutes. Absolutely nailed the timing there, Zach. Great job. So if there's any other questions, we can take them.